Hello, everyone, and welcome back to another Engineering 101 podcast. Hi, Thomas. How are
Hello.
you?
Hello.
So, Thomas, yesterday I was watching a movie, and in the movie, there was this big crane that was taking these big metal equipments, like constantly huge ones, very heavy ones, and it got me thinking how the cable of the crane can take all of these heavy things without breaking.
Okay, so if you want to understand this, you have to look at the main part, the cable. So we have to look at the forces on the cable. And
Okay.
therefore, we make some special tests. So in this case, how strong is the cable we get by doing a tension or tensile test?
What's the reason for this test?
Okay, because the people want to know if the cable is strong enough to lift the load.
Yeah, okay.
Of course, the crane must be also stable enough or strong enough.
Yeah.
And which material they can choose.
Okay.
Yeah,
So
because we have different materials and they have all different behavior.
behaviors. Okay. So some are stronger than others.
Yes.
How can they exactly know if the cable is strong enough? What do they test?
Okay. So in this case, we have our material testing here, and we have our specimens.
Okay.
So here we have specimens, copper, aluminium, stainless steel, and brass, for example. And we build it in here.
Obviously, this is not a crane. So what do we need to watch while we are testing the specimen?
Okay, so in this case, we have to look at the gauge where the force is displayed.
Okay.
Yeah? If this is my cable here,
Yeah.
and the load is here, and the cable is taking up,
Yeah.
then we have measure the force at the cable.
Usually, when the specimen or when the crane cable gets dragged, it looks not much different. How can they know that it's changing already?
Okay, so in this case, it is changing, and this we can see at the end more or less, but we only can measure the elongation. So in this case, at the first time, there will happen more or less nothing. And then after a short time, the elongation will become longer and longer. So in this case, at the first time, we have an elastic part.
Yeah.
So if there is less load, then the cable is going
Back to normal?
back to the old size.
Yeah.
But if we have much more load, then we are leaving the elastic part, and then we have deformation. So if you have then lower load on the cable, then the cable is not going back to its old size.
Okay.
Yeah? And at the end, if you have too much load,
Yeah, it will break.
it will break.
Okay.
So then it's destroyed.
Interesting.
So in this case, during our tensile test, we are destroying our probe at the end, of course.
Okay. Okay. So we can start now with the test, so people can actually see what we have been explaining in words. Yeah.
Now I am doing my tensile test. So the probe is inserted here.
Yeah.
At the moment, I have no force
Okay.
to my probe, to my cable, and the elongation is still more or less zero.
Okay.
So in this case, I am turning this wheel slowly, and then I'm looking what is happening. And I have to do this constantly.
Yeah. So it has to be at the same level,
Yeah,
same strength, kind of.
I have to be it constantly. And you see now I'm at a force of 10 kilonewton. And now we have the elastic part.
Okay. So now the part, if when you stop, it's gonna go back.
Now, yeah, but now I'm over this.
Okay. Now
because it's not going
now
back.
it's not going back anymore. Okay.
And the maximum force you can read up at the end of the red arrow.
Yeah.
And now you see
Yeah, it's getting longer and longer.
Yeah, it's getting longer and longer.
Yeah.
I normally have to turn it more constantly.
Yeah. Oh yeah, it's starting
and
to
now
look
it's
like
coming.
it's gonna break. Yeah. Oh, okay.
Okay, don't be afraid.
Yeah.
Make the noise.
Okay.
Okay?
Yeah. Okay, that's very interesting. If we go back to the crane now, after we have seen what happened when we experiment with this, and we go back to our crane, how, when we are testing this, so how much weight can the crane take?
Okay, so in this case, we have to look at the crane. Of course, the crane must be strong enough.
Yes, of
Yeah,
course.
the structure of the crane.
Yeah.
For example. And in this case, we look at the load we want to lift. So therefore, we choose the correct cable. So the crane must be strong enough and the cable must be strong enough.
Okay.
And then we are on the safe side.
So different cranes has different materials in their cable according to what they pick, what they're lifting.
Of course, maybe different materials,
Yeah.
of course, but they have bigger or smaller cables. Yeah. So it's not only like this small probe. So maybe it
thicker.
is twisted.
Yeah. Okay. It's
three
like
or
very, very
four
thick,
or
so it
five
doesn't
of
break.
them.
Okay. Okay. So as we said, like the crane is an example of much bigger example than what we just did here. But the reason that we did this, because in order for us to understand how the crane works, we need to understand the principle of how the material behaves.
Yeah. So material testing is the basics for construction.
For everything. Yeah. So know which material to use for which area.
Which is the best.
Yeah.
Of course.
Okay. Thank you so much, Thomas, for explaining this. It was very informative and nice. And thank you, everybody, for joining us in this episode. And we cannot wait to see you next time.
See you next time.